Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everyone. Thank you for joining us in today's seminar by Professor Said El-Alfy. So today's seminar title is Emerging Biometric Authentication Techniques by Professor Said El-Alfy. So Professor El-Alfy is a professor with the Information and Computer Science Department. He's affiliated with the IRC for Intelligent Secure Systems at KFUPM. He has more than 25 years experience in industry and academia involving research, teaching, supervision, curriculum design, program assessment. In fact, he is an approved ABIT, CSAB, PEV, an NCAA reviewer. And he is also consultant for several universities and research agents in various countries. Professor El-Alfy is an IAAA senior member, and he is an ex-member of ACM and IAAA Computational Intelligence Society and many other societies. His work has been internationally recognized and received a number of awards. He has served as a guest editor for a number of special issues in international journals. He has been an editorial board of a number of premium international journals, including IEEE Transaction Neural Networks and Learning Systems, among many. So without further ado, I will leave the floor to Professor El-Alfy for his seminar. Fadal, Doctor.
Shukran, Dr. Muhammad. Thank you for the introduction. And I just want to say that right now we have a council meeting, and I'm not sure why. But maybe some people will not be able to attend from the department. Hopefully we'll see some people and some of our colleagues will be there. The other thing is this topic is right now one of the very active area in research. And my goal here, or my aim, is to give an overview first about what is authentication, how does it work, and then how it relates to biometric, and several use cases for biometric and some emerging traits and current ongoing research in this area. Of course, I will not be able to touch cover everything, but I will try to touch the surface for several topics. And if someone is interested, he can welcome at any time to come and discuss, and we can have some collaboration to work in this area. So without any further ado, I just want to start with some news. These are just recent news right now that South Korea is launching face recognition in order to do recognition for people who are infected by COVID cases. Also, the banks in Turkish banks, some Turkish banks, they are using face recognition in order for people to make accounts and to do transactions without the need for going to the bank or visiting the bank physically. طبعا with again the pandemic, many this area has lots of use cases in several transportation, even in China. They are using the surveillance cameras right now to do mass recognition. So while you are moving in the street without your knowledge, without your cooperation, your biometric has been collected and you are recognized who you are. So China has a very large database of people, and there is some debate in the regarding the regulations about the privacy of the persons and how it can be protected for this. People are going to be something similar, maybe you can say like cars now, they have plate numbers and they are recognized. So nowadays, your personal identity is everywhere while you are moving. Cameras are everywhere and they are collecting information about you even without your knowledge, especially also with mobile technology and the advances in mobile technology. Lots of things are going, so the privacy is not now protected and it is disclosed. Many people are suffering from this. So I'm going to divide the talk into two main parts. The first part will be overview about the biometric authentication and how does it relate to the other authentication mechanism, and also look at the market share and the progress, market trend, and the advances that have been done. And then I will look at some traditional operation for biometric system and how they work. And the second part will be about the emerging biometric research topic And again, I divided into things related to the modalities and things related to deep learning for biometric, cloud-based biometric authentication, and security and privacy of biometric systems. So the first part, introduction to authentication. We all hear about this. If you want to access any device or unlock any system, there is something called identification, which you say who you are, and then you have to put something to verify this, which we call authentication. So that's what we call the credential or the authenticator that will be used to verify whatever you are claiming it to be. And then you have authorization, some rights or privileges of what you can do. So once you gain access to the system, what can you do in the system? Like if you have a printer or a computer, or if you have an account on a cloud or whatever, what can you do within this environment? And this also have some auditing. This will be used for tracking and logging what is happening, for accountability, and maybe also for financial things related to your account. So we call this is the subject, and we want to authenticate the subject in order to allow him to gain access to some object. So this is the object, and usually the subject is the active and the object is the passive for doing this. Also, we have two different terminology about user authentication or machine authentication based on the subject type. If we look at the elements for authentication, we have the subject, we call it supplicant. We have the object or the passive element, and sometimes this is also attached with an authentication server, which could be the same system or could be another system that they have to communicate with. And then you have the evidence or the credential or identifier, or they call it authenticator in some papers. Also, you have some protocol about how these components will interact with each other, maybe using Kerberos or lightweight directory active protocol or radius or some other protocols for managing the communication between these subsystems. Also, you must have some database or storage, which could be, again, something simple on the smart card, or it could be distributed, or it could be localized in one central place like cloud or a database where you have a collection of biometric traits. Another thing is when we call machine to machine, it's easier because you can identify the machine with numbers. You can use any length. So you can generate random identifications for them. You can use the MAC address with some random keys that can be used to do that. But the human usually is one of the issues is how long I can, because I need to remember something, or I need to carry something, or how long this will be, or how big it will be. It is an issue to authenticate humans. So you need some cooperation from the human side about which mechanisms that can be used. So usually they classify techniques into 4 areas, which is, you call it knowledge-based or ownership-based or characteristic-based or ID-based. And then you have the multi-factor, which you can combine more than one of the previous 3. So you might use one of these, one of that, based on whatever you do. Also, the biometric characteristic can be used for either identification. You can identify the person who you are, or you can do verification. So later when we see matching, it depends on one-to-one matching. So you're claiming some subject, and I want to take your template and compare it against another template. So it will be one-to-one matching or one-to-n. So I just get some biometric about you, and then we have to go and find from the database the subject identity from there. The other thing is for multi-factor, usually we have to combine, as I said, it could be 2 or 3. But again, you don't need to have too many because this will add more complexity and maybe more cost to the system. For example, Microsoft Passport, they are using 2 factors. You need to have a token that will be driven by a PIN number, and then these 2 will be combined to generate a passcode, and the passcode will be used to authenticate you. Another issue that we have to look at is about the local, where we do this authentication. Do we do it on the same machine, or we do it on a remote machine? We do it online. So we have local and remote authentication. So this authentication can be in the same machine, which you again will not have too much issues. But when you do it remotely, you have to add another issue of security, how to communicate. Here, if you are using a password or biometric, you are doing it, you're sending it to the machine, and then the machine will communicate it online through some internet or network that you have. And this authentication server or host, they call it host-based authentication. The second one is if you are using some intermediates, this indirect way. So you can have some intermediary, could be a device, again, hardware or software that can generate a passcode, and this can be done in your side, in the machine side, or it can be done in the server side. So when you have something like multi servers that you need to gain access to them with single sign-on. So this will be something useful for that. You don't have to authenticate for each single server or for each single host. So these issues again can be done with password, can be done by biometric, or you have to combine both. What we are saying here is that you need to have some secure authentication over the channels in order to ensure that there is no replay, an attack, and this is live, not recorded, and so on. This is an example of doing it. For example, if you have the host and you have the client and you want to authenticate this, I mean here the user will submit, I am El-Alfy, this is my ID, my identity, or who I am. And then this one will generate some random number, we call it nonce, that will be used only once, and send a hash function that to be used here for hashing whatever you want to submit later. There is also another one, which is another function. You could consider it as a hash function or as a challenge that will challenge this B. Now the B will generate hash of the password, or could be biometric, or could be the bin number that you have, and also augmented with the random number, the nonce, and then pass it to this function. So now the function cannot be, it's irreversible, so you cannot retrieve back this one. Now, once we receive it, we have to return it back to compare this one to what we have. So what we have, maybe the hash, we have already the hash of the password, but we have to add the R, and then we do the function F on this. Now we'll have like 2 hashes, and we have to compare these 2 hashes on the server side. This can be done also if you are using a bin, a token that will generate a passcode. So in this case, you enter a bin number, and then the machine or the hardware, could be software or hardware, as I said, will generate a passcode, and this passcode will do the same as we did before, which is again has to be stored or synchronized. There should be some synchronization between the server and the token. So whenever you change it, it will update it in the database as well. Later, we see how we do this with the biometric, because the biometric has 2 aspects. It could be static or dynamic, and we'll see how this can be used. So why biometrics? And why people are talking about biometrics and interested in biometrics? Why not password? Because right now we have thousands, or maybe some people have, let's say, tens or 20, hundreds of passwords. And maybe we can share these for many systems in order to make it easier to use and so on. But the problem is you forget, either you forget because you have to make it too long, or it's hard to maybe you write it on a paper and you carry it with you, and maybe the paper will be lost. Or if you are using a token, the token can be stolen and so on. There are issues with this. We have to generate something personalized that it depends on the user. It's more convenient to use. And it depends on the identity of. And the problem is that this something which is the biometric is non-deterministic. The other methods are static. And if I have the password, it's always gonna be the same unless you change it. But the biometric depend on the matching algorithm that you are using. It could be inaccurate, and therefore the result maybe you have false rejection or false acceptance. That will be there. It depends on the conditions, depends on many factors that will be involved, as we will see later. There are issues against biometric that people are talking about, that you have to, for example, to have a device, you have to have some compatible device to catch or to do acquisition for this biometric, but the others could be good in some other issues. So that's why we have to combine sometimes these 2 with short bin number, and with a token, you can generate a passcode of any length. There are lots of the use cases in biometric. We have seen it everywhere nowadays. People are using it in, you see it in school or workplace attendance. They are using fingerprint or maybe palm print or whatever. In digital payment, you have e-wallet, and you have different stores. You go and pay, and sometimes you instead of giving the bin number, you do it by biometric or pay by your mobile. You also use it for a smart card, contact. It could be contact or contactless. It could do matching on the card or match of the card, as we'll see later. Another thing is for citizenship. We have ID, electronic ID for each citizen in the country, national ID. Another issue is about interaction between human and the machines, robots. So you can think like we live with machines as if they are human and they can understand what we are doing. They can recognize us and serve us based on our identity or personality. Also, there are other uses like forensic investigation, law enforcement. It could be used in the medical field for diagnosis. It could be used for emotion recognition and other stuff. So the biometric is everywhere, as we will see. A little bit of history of biometric. It was known a long time ago, even 500 years BC, during the Babylonian Empire, and later in 18,000 century, they started a system to measure some physical properties about persons or about criminals, and this was about measuring hand dimensions, taking some distances from here and there, and this was one of the first early systems. They call it Bertillon system. And then later, after we're getting the photography machine, and people start to have some type of face recognition systems. But again, this was not automated at that time, of course. They just need to take photos, and they can use the photos for criminal and for law enforcement. It wasn't until recent, in 1960s, they started the FBI. They started to automate the fingerprint system. In 70s, they started face recognition. In 80s, they have speech. And 1990s, they have iris. And one of the very famous approaches for iris recognition is John Dugman, which was patented, and it was implemented and used in United Arab Emirates for airport and border security. Later, they have multi systems. This system can have what we call automatic biometric identification system. And it wasn't until 2018 with the first biometric master card. So this again is adding more to the banking and financial era. Now the question is, which biometric can be used? Which physical property or physiological property about a person can be used? There are several factors that we have to consider when we select the most appropriate one based on the level of security that we need to achieve and the conveniences that we need to have in the system. You have to consider something like it has to be universal, so it has to be owned by every person. It has to be distinct, so we can have unique identity that is not matching with others. It also lasts for a long time. We should not expect it to change very frequent, otherwise it will not be that useful. It should have some way to measure or to collect this biometric. Maybe there are issues, but we can't have a sensor or you can't have a scanner that can collect this type of biometric. Other things related to the accuracy, how accurate, the speed, the complexity of the computation, and so on. Maybe it should be considered as well as a factor. And then about the other single human acceptance and the cooperation in using this. Maybe some of the biometrics are easy to do acquisition for them, and people will accept even they are non-intrusive, but others will be intrusive, and maybe they are causing some damage, like iris in the beginning. Unless we have some safe scanner or system to acquire, people was not cooperating to do that. Another thing is about security. It should be somehow sufficiently resilient or robust for fraudulent attacks. This is just a quick comparison about which one very common traditional ones that we see every day: the fingerprint, the face, the hand, the geometry, the iris, the voice. And we can see that the iris, for example, is very highly accuracy very high. However, it may not easy for people to cooperate and use it. So this is one of the issues regarding the iris, although it can last for a long time. The face, comparing it to the fingerprint is more accurately used, but the face has some medium accuracy, but the face can change also over time. And for many reasons, as we'll see, some of the issues related to the face and collecting the faces. Again, the voice is one of the good things that we can use, and it's not easy to to do spoofing for voice very easily, depending on how you implement the matching technique and how do you extract the features related to the voice. Regarding the physical business prospect and the trend in the market, we say that currently they have like 20,000 to 20 billion dollar investment in this biometric globally, and in expected by 2027 that this will be doubled, and almost doubled, and the growth rate, the annual growth rate, will be about 13%. But this again depends on different regions. Maybe will vary from one region to another, and you can see the highest will be in Asia Pacific. They have maybe like 20%. Another thing is related, which biometrics are most used. And you see here the face, the hand, the voice, the signature, and maybe the iris. And these are the top ones that are dominating the market everywhere. And which sector of the market is using them? So you can see here, banking, financial services, insurance are using it. Also, we can see consumer electronics. They are nowadays with the mobile technology everywhere to have, and then they have the retail and e-commerce, and also have the government for identity and citizenship. So these are the top ones for using. Again, this vary from one area to another, one region to another. We don't have the numbers here, but because I don't have access to the report. However, you can register and get access to it from the website. And by the way, you will see that I'm putting everywhere a reference or a cite some reference here for extra information if someone wants to dig down and get more about this. This again, it tells you the factors that are causing high growth rate in biometric, like high-tech access control, like contactless payment, biometric solutions for government, consumer electronics, and digital payments. These are the good markets for biometric right now. There are lots of companies, and I'm just having some of them here. And there is a big list that, again, you can access from this link. And these are the top ones, or maybe the large ones. And they are listed in alphabetical order. So this is some of the companies that are available for this area. Now, how does it work? Usually we have two phases. The first phase will be enrollment. So you need to collect and register this information in a database. The database, as I said, it could be distributed or could be centralized in one place, as we talked about it before. And then the second phase, which is the important one, how to do matching, how to use it, how to verify or authenticate a real entity or subject. This could be for verification, or it could be for identification. As I said, depend on is it one-to-one matching or it's one-to-n matching. And we can see this is this one here. During the enrollment, you have to have collection of biometrics. It goes through some scanners and you get some signal. This could be an image if you have a camera or you have a scanner. This could be a signal, like if you have your voice signal, microphone or something. So you have to have here a signal. We call this is a biometric, and this is a biometric signal. It will go through some processing, depend on the type of signals that you have collect. If it's an image, again, you have to do image processing. And then you find out some feature. We call this is a template representing this biometric. So this will be the biometric template. Again, we'll use this terminology later. We have biometric signal, and biometric template. Now, this biometric template will be stored in some database. And as I said, it could be the smart card. They have some memory to store this value, or it could be in a centralized database or cloud database that you have to store it somewhere. Now, during the verification or matching, what you do the same thing. You have to have, again, the person, you collect the biometrics through the scanner, you do image processing, you compute some template. Now we have two templates. This is the probe template. This is the current user template. We have to compare it against the database. So go and retrieve from the database. We might retrieve only one record from the database if we know the identity that is claimed to be verified. So we just go there and define the corresponding template, and then we go and do some matching. So we have to say how these two are very similar, or we compute the distance between these two. If the distance is high, the similarity is low. If the distance is low, the similarity is high. So there is some what we call matching score that we have to compute in order to say this is accepted or not accepted. Taban, you have to do tuning and select what will be the threshold value. If it's above certain threshold, then you authenticate this to be accepted. Otherwise, you reject. And if you do identification, maybe you find the top 10 or the top 5 that have high scores matching with this one. Another issue here is how to compute this matching. How to compute the matching, you have different ways. Maybe the easiest way is to take the difference and square it. So this will be the square of the difference. And then you take the sum of all the points. So it will be the sum of the squared of the difference. And sometimes also you do it by correlation or normalized correlation. So there is other ways to do. And again, it depends. If you have binary, you can use Hamming distance for matching. If you have binary code, there are multiple ways to do similarity checking or comparison for this. Now, the other point is what type of biometric we have. There are different classifications for this. And we are talking here about the based on the part of the body that we have. This could be physiological or static or stable biometrics. So it doesn't change over time. The same value, it will be always, if you capture, not over time, but what I'm saying is if you capture it now and capture it again, it is the same. Our biometric, I'm not talking about the outcome. The output from the sensor will be different, maybe, but I'm talking about the biometric itself. It's the same. It doesn't change within a certain time. So we have the face, we have the iris, we have the vein. This is something static, and we call it the biometric template. It's a function of the biometric, and this value doesn't change. We assume that it doesn't change for a certain period of time. Even this can be used to identify dead people, because biometric, they have the same biometric, even if they are dead. However, this one, we need the people to do something. We call it behavioral biometric or dynamic biometric or tolerable biometric, because it depends on some value which can change. Like when you speak, you can say this sentence or you can say another sentence. So it's two different sentences, but your features are the same. So the vocal features related to your speech are the same. However, the sentence is different. This is what we call the biometric template. It's a function of X, which can be given. Like sometimes you say, you call a bank and then the bank will say, okay, can you say something? And they give you a sentence and you speak the sentence. So the biometric will change. Just give me a minute, please. So this behavioral will depend on something in addition to the biometric, and the outcome will depend on this too. Again, it can be classified based on the part of or region of the body where it is. It could be the hand. For example, our hand has so many biometrics are there, like the finger, the palm print, the hand geometry, the hand vein pattern. The finger knuckle, it's there, and it could be from the front or the back where we measure and where we take this. It could be something outside, we call it texture, or it could be something inside, like a vein, and we have to get some device to get this information about a vein pattern or vein network. The facial region also have many, like the face is very common, the ear, the teeth, the tongue. Also the ocular region, the ear, the ocular, the eye. If you look within the eye, you have the retina, the iris, the sclera. If you have something like the mediochemical, so this depends on the body, on the DNA, on the heart sound, and so on. It could be behavioral, and there are others. And so also soft biometric are there, like something related to the person characteristic, like gender, ethnicity, height, and other stuff like taboos or tattoos or whatever they have. Now, the other thing, how they work, we have to do some kind of matching. As I talked about before, we have to collect information and do the matching. And this matching could be done on the card. On the card, we have some microprocessor or system, and it's embedded over there to make the decision and to tell you whether this biometric is accepted as in the card or not. So the person will be authenticated. Or maybe you can send this to the server and it will be done in the server. This is called the match of card. So the matching will not be done on the card. How it will be done, similar to what we did before. We have to, again, the user will communicate with the host. The host will send R and E. And then from here, you have to convert the biometric into a template. And then you send the device information as well as your biometric or template. So this encryption will include the nonce as well as the identity of the device, as well as this could be considered as two-factor, because you have the biometric, you have the device, and you are sending this information to the other side. The same thing is done for behavioral. It will get some sentence or maybe something that you have to generate the signal based on. And when you receive, you return it back to the X. You have to retrieve X and also retrieve biometric. And then you do the comparison whether it match or it doesn't match. And then you either accept or reject. There are many biometrics. I'm going to give some examples quickly just to see what type of features are there and how they collect. So if we say, for example, if I have a fingerprint, usually you have the scanner, it will give you an image. You have to do some enhancement for this image, and you have to get the directions, enhance the orientation, and then you do binarization to get this very clear, and then you get something called the miniature. Based on the type of different feature there, you get some points or key points that will be used as a template for that person. The face is something similar, and here we are computing the cosine similarity. So you have two vectors. One is representing this face, this is representing the other face, and then we take the dot product over the magnitude for each. We get the cosine, and it will tell you the symmetry. Another thing for the face, one of the all the ways to do it is the eigen faces. So you can think about faces as signals, and when we do with signals, we have Fourier transform. There is some base signal or harmonic. The same thing for faces. There is some base faces. We call it eigen faces, and we do some projection for a face. This face will be projected in all these different, and we get the weights of the projection. This will represent as a vector. So later on, if I want to reconstruct, I can just take summation of this weighted sum, and I get the face again. If you change the weights, you get another face. If you change these numbers, you get it. But these weights will be considered as a template representing this face. Another thing is using landmark on the face, some key points, and maybe you can make it as a graph or as a network like this elastic graph matching algorithm, and they can do something. The same thing for voice, but you have here to do acoustic analysis, and you get some thing maybe like MFCC, or maybe you talk about transformation from one domain to another, spectral transformation, and you take some features related to this. The same for finger vein. You collect the finger vein, and you do almost the same approach that you have to do enhancement and get some features. But here you have images, and you are dealing with the texture. So in that case, you can use something like LPP, or maybe you use Gabor, or maybe use Wavelet, or maybe something else like SIFT or other stuff. Iris has some different way to do it. Once you get the iris, you can do normalization and convert this into a binary code. And then later you do matching between these two codes by Hamming distance. There are different sensors available in addition to visual cameras that we normally have, but there are other depending on the infrared, which can give you more invisible features related to the biometric or the traits that you are measuring. So there is something here depend on where you do the, this is the spectrum for all different light and visible and invisible range. You can see the spectrum for the infrared where it lies, and what type of infrared devices we have, like near infrared, medium wave infrared, long wave infrared. Also, they have this electromagnetic, and they have different passive and active, and where they fall. Later, we'll see some of these are used for collecting maybe other type of biometrics, which are hard to collect, and you have to use some of these devices. Like Microsoft, مثلا Hello, they are using special camera that can collect your face. So once it will recognize you, it will unlock your computer. Another thing is about the research directions, where the research is going on. We can classify it into maybe 3 different directions. The first one is development of resilient, secure, reliable, scalable, efficient systems. And this can be done by enhancing all the components. So you need to enhance the sensing, you need to enhance the feature extraction, the matching algorithm, and the communication protocol to be more secure. So all different levels they are. Another thing is about new application areas where it can be applied and can be used, some use cases or new use cases for the biometric, and integration with other technologies. Nowadays, we hear about robotics, as I said, and they are working at home as if they are human and they can recognize people and help them. Blockchain, IoT, smart connected vehicles, drones, surveillance cameras. Again, all these technologies can be integrated and can use the biometric. And there are lots of research. I will show you some of them later related to this area. So some of the emerging traits, I'm gonna just focus for a while on the face. And the face has several challenges, like maybe you have low quality image quality, could be have shadow, you have low resolution or contrast, maybe illumination or light variations, maybe the position of the person, it can change, so you need some controlled environment or cooperative person, because if you take a picture from this side, it might be better than if you take it from another side. Also the facial expression, the accessories they have, the cosmetics, the plastic surgery. So there are many issues related to the face that will again motivate that we need other types of maybe features or other type of biometric or other type of sensors that can help you to collect. And maybe many of these can be at the same time. Yani these are not exclusive, they may overlap. Another thing is about the interclass. You have similar persons, maybe father and son, twins, maybe cousins. They are very look like, or sister, they may look similar. This is called interclass similarities. Another thing is about spoofed artifacts like deep fake nowadays. If you go there, you can see many people, they are automatically generated, and these faces are not real. So we call this is a real person, but this person doesn't exist. If you look at another one, this again generated by the computer, and this person's this person don't exist. Another thing you have to is the model complexity also can add issues to the face when you do the computation. So one of the research direction is using other type of cameras, as I said, and the thermal infrared camera is used in 2018 by US Army Research Lab. They developed a system that can recognize people even in dark, even if you are in a place where you can't see the person, or you have very faint light, you can still recognize the person. Another thing, even you can reconstruct a visible person from this image. So you can have this one and go to this one, although this is not, you don't have this camera, you can go from this image to this image. So this is an interesting area of research that people are working on in order to do cross-domain and do adaptation for within the same domain work. Another type of traits, I can talk about some others like ocular. If you look at the region of the eye, there are lots of features over there that can be utilized in order to improve the biometric features or templates that we collect. Other thing related to periocular. Periocular is the area beside the eye. So there are other features related to this area, which is related to the eye or around the eye that can be also used. One of the good things is the eye movement, the gazing. Yani eye movement can tell you a lot about the person. It's not only for biometric to identify, but even about the personality, about the mental behavior, about maybe drug consumption. So looking at the eye and looking at some of the features related to the eye, you can tell, this is what they say, your eye is العين فاضحة يعني. When you speak to someone, you have to look at his eye. So why? Because you can detect more information and get more than what you hear from him. Another thing is about the vascular biometric, and this is, as I said, it could be something inside the hand. It could be from the front or the back, dorsal or verticular. It could be in one, maybe one finger. It could be in the whole hand. And these are different places. This is in the BAM. This is the BAM vein, the wrist vein. This is the BAM vein. You have here the arm, the finger. This is just one finger. This is the arm. You have here about the arm. And again, this needs some special kind of sensors that can collect. And the good thing is that these sensors can give you more than one. You have multifunctional sensor. So the sensor can not only give you one characteristic, it give you several characteristics at the same time. So you don't just rely on the fingerprint, but also you capture additional information related to that. But this is some of the sensors. You can put the sensor in the same side, or you can put it in two different sides. and you can get the information related to this vein in the body. This is about the nickel. If you look at the back of the fingers, you have some features here or texture here that can be used. Here the texture is different, and you can recognize people by this. Even the nail, if you look at the nail, they have some, again, curves or grooves over there that can help to build some biometric related to this is not all accurate, this is not all, but these are emerging areas where people are expecting it may help, or it may give additional information that can improve or add value to the current ones that we know. This is the sclera recognition. Again, you can look at this sclera area, and you can find the blood veins in this, and you can form some kind of landmarks or network or graph, and then you can recognize. One of the nice areas that I worked in a lot with one of my students is the gate biometric, and he has even done some patenting patents for this area that you can recognize based on the silhouette of the person, even if he's in far away, maybe 50 meters, you can still recognize people at that far distance here. So I'm not gonna talk about all of the features related to it. Another one is the air. If you look at the air, also they have some features that can be characterized or measured. Again, there are some papers related, as I said, and I'm putting one at least here. You'll see in the bottom some citation for at least one of these papers. The tongue, if you look at the tongue, they have also some, in addition to the chemical stuff you have in mouse, you also have related to the tongue texture. You have some extra information and the shape, the measurements that you have, and so on. This is about the EEC. From the brain, you can take some signals and you can think even what are you thinking of right now and what you are maybe planning to do in the future, and so on. The heart and the heart sound signals is one of the areas that, again, investigated for doing some kind of work related to biometry. One of the very interesting area is when you combine many of these. This is called the multi-biometric systems. And when you say multi-biometrics, there are like 5 different directions of doing a multi-biometric system. So it might be 2 different biometrics. So you have multiple biometrics, like ear and face, like maybe face and voice. It may be multiple sensors, but the same modality, the same traits that you have, but you are taking it from different. Like we said, the face, we have thermal camera and we have visual camera. We have depth information. We can build this 3D shape. So you have some extra sensors to collect extra information related to, and you fuse this information together. It might be also something related to the unit itself. So you have right index and the middle index. You have multiple fingers. So you don't just rely on one finger. You rely on other fingers, but still this is fingerprint. Another thing is you can take several shots. So you have several shots or several attempts. We call multi-image or multi-instance biometric recognition. So you have multiple of the instances, and I'm using this to merge information and get. Another thing is about maybe the matching algorithm. So instead of just relying on this miniature, you can use also non-miniature and do matching. So I get some score from this, some score from this, and maybe even some decision from this and some decision from this. And then I can do the fusion of these 2. So these are different directions for multi-biometric systems when you think of merging them. The second question is where to do the merge, where we do the fusion or integration of this. It can be done at the sensor level. So you collect 2 images, but then you want to have one image that combine information from these 2. So this will be coming as sensor fusion that you merge at this level. Another one is to do feature extraction. So now the raw data will be converted into some feature, which is reduced dimensionality of the information that we have. And then you combine this again. You combine this into one, and then you can do the rest to be the same. So we have feature level fusion. Again, you can do after the model, after the classification model or the matching model, you can do this at This we call it score level fusion. So each one will give you a score, and then we want to, this is like when you have a committee and everyone is giving a grade for a student, and then you are combining the grades, maybe by taking the average, maybe by taking the maximum, the minimum, product, sum, whatever. There are different ways to measure this value. And then another is maybe after the decision. So each one will decide either pass or fail. It will be kind of like maybe binary in authentication. And then we have to merge this, maybe like majority vote, or maybe by other, maybe meta. Maybe you can use like meta classifier or meta matching approach. This is just one example for this multimodality. We're using here face and voice. And this will go through the feature extraction, and then you do fusion at the feature level. We call it you do augmentation or combining these two together. It could also do some transformation here before you do extraction. And then after even you extract, you can do some transformation. So somehow you fuse these two. It could be just by simply augmenting, as I said, and then you do the pattern matching at this. So this will represent your template. The same thing here is done, but at a different level. So you do it at the score level fusion. After each one of them decides the score, then we can combine these two. So sometimes we call the crowd can have extra value, yani, can add to help in making better decisions. One second approach Professor, is deep learning. Yes.
Dr. Alfy, if you can wrap up in 5 minutes so that we can have time for a couple of questions. Just a reminder.
Sure. We started late, maybe 5 minutes. Okay.
Yes.
So
we just to wrap up at 3 p.m.
You have taken 10 minutes to introduce me.
Okay. Well, if you can, 7 minutes.
خلاص, inshallah, no problem. I'll try my best. Thank you. The second area is deep learning, and this is one of the booming areas. Instead of having features and building templates and doing the matching for the templates, these two are built and learned in the same model. So like something like a convolutional neural network, they can learn going from the raw data up to making a decision. And again, this can be done in a variety of ways. We have autoencoder, we have maybe GANs. And again, I talked about this person doesn't exist, like deep fake and generating new samples and the new systems are there. Regarding face recognition only, I'm focusing here on one, but there are many others. I'm just here as an example of how much recent research has been conducted just on one biometric trait. And also there is some survey papers that you can read and get more information from this. As I said here, the deep face was in 2014. And then following this, you have several systems that have been implemented related to this. This is one of them, the FaceNet. They try to compare an instance against a positive instance and a negative instance, and then they try to minimize what we call the triplet loss function. So you maximize the distance between the instance and the negative, and you minimize the distance to the positive case. So this is the function that the network has to learn. Second or third area is the cloud-based biometrics. So this, again, we're gonna store the data where in the cloud. How do we store the data? And here we worry more about privacy and how can we do the computation on encrypted biometric. So this is area of, we call it maybe federated computation or federated learning. And then how can we use this in order to build more robust biometric systems. Last is the security related issues of the biometric systems. We talked about the system before. We have sensors, we have feature extractor, we have matcher, we have database, and we have some application device. And again, each part or each component can be vulnerable, can be sensitive to some type of attack. So the attack is not only in one particular part. I can attack the sensor, that's called the presentation attack, or I can attack the feature, or I can maybe the matcher, or even during the transit, during the communication. So I can do something like interception for the communication and do some tempering for the biometric, or maybe introduce some other biometric or change the decision that is made everywhere. So there are issues related to all authentication, which is common, whether it's a biometric or not biometric, like bypassing authentication, default credentials, sniffing credential, replaying, downgrading authentication, imposter servers, man in the middle, and many others. These are common for all type of, and then something related specific to the biometric, like liveness. Is it alive or it's not live? So usually we say this is the Turing test. that you need to build a machine that a human cannot tell whether it is a human or a machine. This is the Turing test. However, here it's the reverse. We call it the reverse. We need the machine not to be able to distinguish. In our case, we needed to be able to distinguish between a human and a spoofed human. This is something like a bot or something like an artifact created. It's a video. Maybe you can record my video and then you can use my video as my biometric, since you can recognize. But again, there are techniques that can be anti-spoofing and liveness detection. So there is a paper called liveness is more important than maybe secrecy, or you need to, in the biometric, it's not only enough to have secure biometric or a strong biometric, but also you need to detect this liveness as well. Other thing is related to the template itself. How can we protect the template? Because there are lots of issues. If I forget my password, I can maybe change it, or I can use another key, or I have different ways to change the key, but what is about biometric? How can we change it? It's hard. We cannot. We need to think about something called the cancelable biometric. How can we cancel the biometric if it is compromised also? The point is that the idea is using something like biohashing or irreversible. So are using some random number that will be combined with the biometric. So if the biometric, you are not talking about the biometric, you are talking about the outcome of the biometric system. But this outcome of the biometric system will change because one of the input component is changing and so on. Another is the crypto systems with biometric crypto system like fuzzy extractor. Another area is biometric and the encrypted data like homomorphic and maybe the differential privacy to protect the privacy can be used, and the integration with blockchain. This is just one system. I'm gonna just explain quickly that using the biometric, you do some transformation, and then you have some random numbers that will do inner product, and then you compare this against some score, against some threshold, and then you can binarize and get the biometric that will be done. This is about the blockchain. It's one of the papers saying that it's better to do it for the database itself, and this can be done in 3 different ways. It can be done as full on-chip, on-chain storage, or maybe you can use it as data hashing and integrity checking for these contracts. Finally, I'd like to say that biometric is an integral part of penetrating our life, and it's an active area of research. It is integrating now with lots of other research areas, and the privacy is one of the top debatable issues that has to be addressed. Also, legislation on how to protect people's privacy, because even if you are not, I am collecting information about you and you don't know, and you cannot change. Password you can change, but biometric you cannot change. Thank you at the end for your attention and for attending. I hope I covered, and I was trying to cover as many as I could, and I hope to hear from you. And again, if you have any questions, you're welcome to. One last is I have a call for book chapters. So we have a book coming by CRC Press. It's about intelligent video analytics. If you have any area or any paper or any chapter related to this area, you are welcome to submit. You can just search for this easychair.org /call for paper /IVA, intelligent video analytic, and 2022. Thank you so much. I appreciate, and sorry for taking maybe a few still I think within, but I appreciate your time, and thank you so much.
Okay, thank you, Professor El-Alfy, for the round presentation about biometric. So do you have any questions, audience in the room? I remember there was one hand risen by Hussam. If you still have question, I think he's offline. Anyways, I don't think there are any questions. So on behalf
of I can go back and explain the rest.
Sure.
I apologize. I was trying to be more informative and collect, because the area is very big and there are many issues to cover. But still, as I said, everybody is welcome. We can chat, we can talk at any time you want. And as long as we do research, I love. It's my passion to do research. Thank you.
Excellent. I think there is one question here by Dr. Alawi Sagaf.
Assalamu alaikum, Doctor. I want to ask, I have one question that how biometric features protected in database or in the server on the smart card
Yeah, I covered it quickly. If I remember, you go here in this area. We said these are 4 different directions you can do to protect it on the template. This is biometric template protection. So most of them they are using, for example, you encrypt the biometric, in brief, this is one way to encrypt and maybe decrypt, but the privacy will not be protected. Or you are doing hashing on this. So using something to hash, because the hash is irreversible, so you don't worry about returning it back to the biometric. It will be used for integrity checking, and you want to use it to check the integrity of the biometric.
Okay, thank you.
This is in brief, but again, if you are interested, we can talk about it more.
Yeah. Actually, I'm working in this area in biometric security. So, I did a lot of work in this biometric crypto systems, and we found that this biometric crypto systems degrade the performance of the systems and even the security. So, inshallah, I will visit you. We'll talk about this. We'll work.
I can't disagree with you. This is, of course, the more you do, the more you are downgrading. But there should be other issues that you have to do in order to improve. That's why research is always open for ideas.
Inshallah. Thank you.
Thank you.
Dr. Abdul Malik Zaiduri has a question.
Dr. El-Alfy, I just wanted to, if there is any research about this deep fake and how we can differentiate between real speech or authentic speech or fake speech. And
yeah, well, this is an excellent area, Dr. Forensic of in image forensic in general, and one of them is about the face. How can you differentiate generated face from a non-generated face? And I have seen lots of attempts using even deep learning technique to differentiate between a computer generated image and between a real image. And as I mentioned before, if you maybe one of the quick way is to do it is by using a new sensor, some type of sensor that can give you information about the micro expressions you have in your face, or maybe even the blood. You can collect information about the blood from the sensor, which doesn't have to appear in the computer generated one or the video recorded one. So they use something to see the liveness of this. If you are doing it real, or you are doing it at certain times, the device sometimes it can, for example, do blinking. So the eye or the bubble can move or it changes based on the lights that you are emitting to the eye. So this another thing is the heat generated from the face. When you are close to the camera, there will be some type of heat to differentiate, which may be not, or vice versa. This is another thing, thermal features related to the face. I hope I quickly covered.
Thank you.
Thank you.
Okay. So again, thank you, Professor Alfy, for the accepting the invitation and giving an excellent presentation. So on behalf of the all faculty of the Intelligent Secure Systems, we thank you again, and hopefully we'll have more presentations or more seminars from your side in the future.
Jazakumullah khair. I thank you again for inviting me, and it's my pleasure always to cooperate with all. Jazakumullah khair. Thank you.
And thank the audience for joining us as well.
Thank you so much.
Take care.
Thank you. Assalamu alaikum.
Salam.